Okay, so this is problem 15, the roller coaster. And let's forget about the roller coaster for a moment and just look at this function here, y equals 65 cosine x. I think it's obvious why I chose 65 for the amplitude. And let's just see how y varies as a function of x. Just review. But to make a point, if this is our starting point at x equals 0 and y equals 65, the period refers to the interval for one complete cycle. So a complete cycle means that we get down here to the minimum at pi, that's half a cycle, obviously, and the full cycle means we return all the way up to 65 again. So the way this graph is drawn, the period equals 2 pi. But let's erase this and make this 260. And this, whoops, this is 520. So now we've got a roller coaster. We've got a car up here, and it's going down to the bottom of the hill. So it's, if this sinusoid is a good model of the path of the roller coaster, and it may not be, but we're assuming that this is the, we're using this model because it's a good approximation, let's say. So when it gets down to the bottom, it's only gone through half a cycle. And that is why 260 equals 1/2 of the period. So the period, in fact, does equal 520. And because, obviously because it's 260 instead of pi, we need to put a b in here to show that there's a change in the period. And yeah, just we know from, but we know by memory now that b equals 2 pi over the period, 520. So b equals pi over 260. So that's what that's all about. The other thing, of course, is we forgot about k. K is the vertical shift, and since the top of the hill is not 65, it's 100, that means k must be 35. So that's all. It's just a reminder that the bottom of the hill only represents half of a complete cycle, or half of the period. By the way, if you're taking physics now, or you're going to take physics, you might be interested to know that if hypothetically there are no frictional forces between the wheels and the rails of the track, and there are no frictional forces between the wheels and the axle. In other words, there's no energy loss due to friction. The conservation of energy principle will tell you that if the roller coaster starts up here from rest, it'll come all the way down, gather speed, and then go all the way back up to the hill and come to rest right at the top of the next hill, assuming that the next hill is exactly the same level as the first hill. So anyway, I hope that helps.